Namaste and welcome to today's Explainer. We are about to embark on a truly epic kahani, a story about a hero whose journey is completely invisible to our naked eye, yet it literally shapes our entire everyday experience. We're talking about the incredible, often surprising journey of a sound wave. So let's just dive right into this scientific adventure.
To kick things off, I want to pose a bit of a mystery. It's one that kind of challenges everything we naturally assume about how the world works. Picture two astronauts floating outside a space station. They're working hard, doing some repairs, and suddenly they accidentally smack two heavy metal tools together. The question is, do they actually hear that metallic clank? Take a second and really think about that based on your everyday experience.
So imagine those exact astronauts at work above the Earth. To solve this deep space mystery and figure out if they can actually hear each other or their tools, we first need to understand how our hero, the sound wave, is born. We've got to start at the absolute beginning of its journey.
Chapter 1. Avaz Ka Janam, the birth of sound.
Every great story starts with an inciting incident, right? A spark that sets the whole thing into motion. Well, for sound, that spark is always a vibrating object, like a beautiful traditional musical instrument, the tal. Science tells us that sound is actually a form of energy. And, as we know from basic physics, energy can neither be created nor destroyed, it just changes form. So, the journey of sound always begins with a physical vibration. The moment a musician strikes two metal pieces together, they vibrate. That mechanical vibration is the exact instant our hero, the sound energy, is born.
Chapter 2. The Invisible Highway. Medium.
Okay, so our sound energy has been successfully born from that initial vibration, but it can't just stay there. It needs a path to travel on to actually reach your ears. This path is what we call a medium, whether that's a solid, a liquid, or a gas. Without this physical rasta, this actual material medium, our newly born sound energy is completely trapped right at the source. It literally has nowhere to go and just cannot move forward.
And that brings us right back to our opening space mystery. Space, as you probably know, is a vacuum. And a vacuum means there is absolutely no matter, no particles, no medium whatsoever. The math here is incredibly simple. Vacuum equals no medium, which equals no sound. So the answer to our mystery? Those astronauts hitting metal tools together? They hear absolutely nothing, just total silence. The sound energy is born from the vibrating metal, for sure, but without an invisible highway of air or water to travel on, it can never reach their ears.
Chapter 3. The particle dance, sound waves.
Now that we know sound absolutely requires a medium, like air, to travel here on Earth, how exactly does it move through it? Well, to figure that out, let's create a little mental flipbook animation. Picture a tube with a piston on the left side, and all these tiny dots inside representing air particles. Right now, the piston is just at rest. The particles are hanging out, evenly spaced, at their normal average density. This is the calm state before the sound energy arrives. Now watch what happens when the piston pushes forward rapidly. This represents our vibrating object pushing into the air. Boom! It physically shoves those air particles together. This supercrowded, high-density region is what scientists call a compression. But remember, the vibrating object doesn't just push outward, it oscillates, meaning it pulls back too. When the piston pulls backward, it leaves behind this empty, low-density space right next to the compression. This spread out, far less dense area of air is called a rarefaction. And here is where the absolute magic happens. As the object vibrates back and forth continuously, it creates an ongoing chain of these alternating compressions and rarefactions. The disturbance, that changing density of air, is what actually travels forward all the way down the tube. The individual particles themselves? No way, they don't shoot down the tube. They're just doing a little back and forth dance in their own spots, simply passing the energy along to their neighbors. Because of the specific way these particles dance, scientists classify waves into different categories. Sound is what we call a longitudinal wave. That means the particles of the medium vibrate parallel to the direction the wave is traveling. They move back and forth in the exact same line that the energy is moving. This is very different from a transverse wave, where particles would move up and down, completely perpendicular to the wave's path, kind of like ripples spreading out on the surface of a pond. So, putting all of our science together, because sound relies entirely on this parallel particle dance, and because it absolutely requires a physical medium to propagate, it is officially classified as a mechanical wave. Simply put, no particles, no dance, no wave. Chapter 4. Energy, Mics, and Speakers.
Okay, our hero is born from a vibration, and it's successfully traveling across the invisible highway through a microscopic particle dance. But let's talk about how we actually capture, recreate, and interact with this traveling energy using everyday technology. Think about the very device you're using to listen to this explainer right now. A microphone is essentially an energy trap. It captures our hero, the sound vibrations, makes a tiny internal diaphragm vibrate, and converts that mechanical energy into electrical signals. Then, your speaker does the exact opposite. It takes those electrical signals, uses them to vibrate a cone, pushes the air into compressions and rarefactions, and brings the original sound back to life. It is a beautiful, totally perfect loop of energy conversion.
Now, every single sound wave has a unique fingerprint. If our sound wave is a hero, amplitude is their strength, basically how loud they are. Speed is how fast they sprint through the medium. Wavelength is the physical size of their footsteps, and frequency is how many steps they take every single second. But here's a wild fact to consider before we wrap up. Our human ears are only tuned to receive a very specific channel of this energy. If these mechanical waves vibrate too slowly, like below 20 oscillations per second or 20 hertz, they're called infrasonic waves, and we simply cannot hear them. If they vibrate incredibly fast, above 20,000 hertz, they're ultrasonic waves. These are also totally invisible to our ears, even though animals like bats rely on them every single night to navigate and hunt.
Chapter 5, Kahani Ka Saar, the summary.
So the entire complex journey of sound is wonderfully clear once you break it down. Step 1, a physical vibration creates the initial sound energy. Step 2, that energy disturbance enters a physical medium, like the air around us. Step 3, the particles in that medium perform their parallel dance, creating alternating compressions and rarefactions. And remember the golden rule here. It's the density disturbance that travels across the room, not the particles themselves. Finally, step 4, that traveling energy reaches a receiver, like your eardrum or a microphone, where the physical journey ends and your actual perception begins.
To cap off our explainer today, I really want to leave you with a mind-bending thought. Look at the empty space in the room around you right now. Just look at it. What if human eyes could actually see these invisible longitudinal waves? Imagine seeing the air itself physically pulsing with compressions and rarefactions, visibly carrying conversations, music, and the hum of the world in this massive overlapping dance. It really makes you realize that the empty space around us isn't empty at all. It's a bustling, invisible highway of energy. Thank you so much for joining me on this journey. Keep questioning, keep looking closer at the world around you, and I will catch you in the next one.